Hello everyone! Do you ever wonder how we went from ancient theories about atom being tiny unbreakable particles to understanding electrons flying around in specific orbits? Well, today we are going to break down Niels Bohr's atomic model, one of the most mind-blowing ideas in the world of science. In our previous video, we have already taken a look at the J.J. Thomson's Plum pudding model and Rutherford's nuclear model. However, there were many questions left unanswered, such as how do electrons stay in orbit around the nucleus? Why don't they spiral into the nucleus, collapsing the atom? That's where Bohr's genius came in. Let's get into the core of Bohr's groundbreaking model. In 1913, a brilliant Danish physicist, Niels Bohr, proposed that electrons move in specific orbits around the nucleus, kind of like planets orbiting the sun. In Bohr's model, these orbits are called cells. Cells are not random, they are quantized, means only certain cells are allowed. The innermost cell has the lowest energy level, and as you move outward, the energy increases. Now, the really cool part, electrons can jump between these cells, but they can only do so by absorbing or emitting specific amount of energy in the form of light. This was huge. It helped explain why atoms didn't just collapse into a giant mass of particles. Bohr's model rests on three main postulates. Let's break them down one by one. First one is electrons move in fixed orbits around the nucleus without radiating energy. Second one is electrons can jump between these orbits by absorbing or emitting a specific amount of energy. And the third one is the energy of each orbit is quantized, meaning the electrons can only have specific cells or energy levels. These cells are named K, L, M, N, and so on. The quantum number of innermost K cell is 1, 2 for L, M cell has 3 number, and so forth. The maximum number of electrons in a cell is given by the formula 2n square, where n is the principal quantum number of the cell. The first and the closest K cell to the nucleus has the lowest energy and can only hold 2 electrons. Next up, the L cell can hold up to 8 electrons. In such a way, we can get maximum number of electrons for each cells by substituting the value of quantum number of cell. Bohr's model was a massive success. It helped explain the hydrogen atom and its spectral lines. In fact, it worked perfectly for hydrogen. He won the Nobel Prize in Physics in 1922 for his work in understanding atomic structure. However, here is the twist. Bohr's model worked perfectly for hydrogen. But when it came to more complex atoms like helium or lithium, the model didn't quite hold up. It couldn't explain certain finer details of atomic behavior, especially in larger atoms. While we have moved on from Bohr's model to more advanced theory of quantum mechanics, his work remained a cornerstone of atomic physics. Without Bohr, who knows how long it would have taken us to understand the fascinating dance of electrons in atoms. Thanks for watching. If you loved this video, give us a thumbs up. And don't forget to subscribe for more science stories. I'll see you in the next one.